We are going to perform analysis of variance. That is when you want to compare the means of more than two variables. For two variables, you can use the t-test, but for more than two, we have to use the ANOVA. And we are going to demonstrate this here. We are going to type in our script. So instead of the console, we can type in our script. And we are also going to use the data built in our studio. Okay. To obtain that data, we are going to demonstrate how to obtain that data, but let us use our typed in commands already. Copy and paste in the our script. Make sure you put hashtag for what you do not want our studio to recognize as a command. So if you want to see the list of variables, the list of data set that is in R, you can just type, leave this parenthesis blank, data and blank, and you run it, and it will give you a list of all the different variables in R. Orange is present somewhere. Okay, the variable orange is there somewhere. So if you carefully look, here is orange, growth of orange trees. It's a real experiment that was done, and the data was collected, and was implemented in our studio, and we can use this data. And any analysis we make on this is genuine because this is real data. So let's exit there, ours, and let us type orange inside there, quotation marks. Orange, call up the data set orange, and you click by the command that you set, and you run it. If it was in console, you would have just pressed enter, but because we are typing in our script, we go to run, and here is the data set orange. Here it is, data orange. We can click on it, and here it is listed. It has 3 columns, one for tree, one for age, one for circumference. We're going to compare the circumference of the different categories of trees. There are 1, 2, 3, 4, 5 categories of trees. We are going to compare the means of these samples, okay, of the 5 categories. So let's just verify the heading of this table. Click on run. As you can see, tree, age, and circumference. Let's get a summary of this data set. Click on summary. And as you can see, the minimum, first quartile, median, mean, upper quartile, and maximum value of the age and the circumference. And the trees now, each category has a sample of 7. We can verify the levels of the tree. As we see, it's 5, but we can just verify it. Here they are, 1, 2, 3, 4, 5 levels in the variable tree. So now we are going to extract the variables of circumference and tree. That's what we are interested in, because we're going to compare the circumference of each category of tree. So we're going to indicate to our studio to recognize a new variable called circumference and a new variable called tree. So that's why you type circumference equal and orange $ circumference, and you run this there. So as you can see, R has recognized this new variable called circumference, and it will be same for tree. And here these variables are extracted, and as you can see, they are listed here also, tree and circumference. Before we go into the ANOVA, if you want a visual of the means of the different categories, create a topic called compare mean of circumference of the different trees. So if you click on this one, it will give you the mean of category 1. There it is. Click on this, it will give you the mean of category 2. So this is a manual way of getting the means. As you can see, the sample means are slightly different, as you can see. So we have 1, 2, 3, 4. Category 4, well, we did it already, and category 5. That's manual inspection. But if we want to see the means, if we want to, let's say you have 10 categories, that would be very cumbersome, 20 categories. So here the tapply is a function you can use to give you the means of all the categories in one click, and here they are. Okay, and as you can see, the sample means are different. 94 is different from 129, but 149, but we have to recognize that we have to bear in mind that's a sample mean. So we must do the test to see if this applies to the population. Here we can apply tapply also to verify the count of 7 in each category, a sample of 7 in each category. Also, we can present the data using a box and whiskers diagram. It's called data presentation. You type box plot, circumference, the tree, main, that's the topic, the heading of that box and whisker diagram, and we'll label the X tree category and the Y label tree circumference, and give them different colors, rainbow colors. So let's just copy this and paste this here. Okay. So now we can go here and just type enter, run, sorry. And this gives us a visual inspection of the presentation of the 5 categories. As you can see, they have different values for the mean, but that always bear in mind that's a sample. Okay. So let's go to the ANOVA to see if the sample differences are significant, if they can be applied to the population. So we have hashtag ANOVA analysis. Here's the AOV function, circumference to tree, and we can type in this. Here is a manual calculation of the F value, all right, 0.88. And here we create a new variable called output, and the summary of the output, ANOVA will give us, R will give us a summary of the ANOVA test, the classical output of an F test that we are familiar with. So we copy and we paste this there. First, we're going to call up the ANOVA values to run, and here they are. Here it is. We have the residuals and the tree and the residuals. The sum of squares and the degree of freedom, 4 and 30 respectively. Here we can do a calculation of the F by using these values. Sum of squares divided by the degrees of freedom from the tree, in turn divided by the sum of squares for the residual divided by the degrees of freedom. We get 0.883. Okay, now we can get a direct calculation with using the AOV directly, ANOVA, but we created a variable called output. Let us make our recognize this variable. Let us run this. And a summary of this output, as you can clearly see, here it is, and the p-value is 0.486. Here's the verification of the f value, 0.88. Now, since the p-value is greater than 0.05, we're using 0.05 as our significance level, then we do not reject the null. Okay, let's copy this and place this in our script. And the null says that all the means are equal. mu1, mu2, mu3, mu4 are all equal. The alternative is saying at least one mean is different. The significance level is 0.05. The p-value, if the p-value is less than the significance level, we reject the null. If not, we do not reject the null. Or p-value of 0.486 is greater than 0.005 alpha, so we do not reject the null. There isn't enough evidence to conclude that the difference in the sample is significant. So in conclusion, the population mean, okay, let's start with population to know the difference between the sample mean and the population mean. So although the sample means showing some difference, we cannot apply this to the population means because the difference is not significant because the p-value is greater than the significance level. So in conclusion, the population means of the circumference of the trees are equal to each other according to the null hypothesis, because the null hypothesis was not rejected. So we have to conclude with what the null hypothesis is saying, that the population means of the circumferences of the trees are equal to each other.